Hi there. Welcome to another exciting session on AI. Today we are diving into something that is gaining a lot of traction in the recent times in the agent ecosystem, MCP or Model Context Protocol. Think of it as a new kid on the AI block, a protocol that is making AI agents smarter, cleaner to build, and much easier to scale. If you have worked with tools in LangChain or any other AI framework and you have used a tools to connect an agent with the tools, you might have probably dealt with a lot of glue code or plumbing required to connect these agents with that tools, right? So you have a lot of formatting logic and handling some edge cases just to get your tools working with the agent. Well, MCP fixes a lot of that pain. In this session, I am going to walk you through what is MCP, why it matters, how it compares traditional APIs, and then we'll dive into a real world example of building a travel planner agent using MCP servers. So we'll create two MCP servers using real world APIs like Flight API, Hotel API, Weather API, and Location API to build a travel itinerary, travel planning from a source to destination depending upon different parameters. So it is going to be really exciting where I'll walk you through a detailed code walkthrough. I'll explain, going to talk to you about a step-by-step process to build an MCP servers and how we can actually connect them to an agent. So by end of this session, you will have a clear understanding of how to use MCP to build more powerful and modular agents. So stay back with me till the end. And with that, let's get started. So before we get into MCP, let's talk about the core building blocks of intelligent AI system today, agent and tools. When most people first interact with a language model like a chat GPT, it feels magical, right? You ask a question, you get an answer. But you're only scratching the surface of what is possible. Real power comes when we go beyond simple Q&A and turn these models into agents, systems that can reason, make a decision, and most importantly, take actions. But here is the thing, right? Agents are only as good as the tools they can use. Think of an agent like a smart assistant. It can think, but without tools, it can't do anything. Let me give you one example. So we are going to build a travel planning agent today as part of session. So if you ask regular, chat GPT or any other LLM model, which is not equipped with any other tools, then you say, find me cheapest flight from New York to Tokyo next month and suggest places to stay. A regular LLM might give you a general travel advice or maybe the prices which are outdated. But an agent with access to a Google Flight API or Google Hotels API or Google Maps API can actually go out, fetch real-time flight data, compare prices, look up hotel options, and even suggest a local attraction depending upon the user preference, all in single conversations, right? Take another example. Say you have internal support bot, you can just ask it a question. Hey, can you get me last quarter sales data for Northeast region in US? Without LLM, it can just only guesswork. But with an agent with access to your internal database, it can execute a SQL query or maybe API which the database which has got access to the database and then get the real-time data and then give it to LLM so that LLM can actually take the real-time data and then do the reasoning or summarizing or answering some questions. It can do everything. So basically what we are doing is think like LLM like a chef which can do any type of which know how to cook, but it may not know your secret sauce or secret recipe. So we are giving that chef a secret sauce or secret recipe which will help the chef to build, cook something which is of your own recipe, right? That's what agents are doing. Agents are you are actually equipping LLM with the real world information or the information which is very specific to your enterprise so that agent can take that information and then do the reasoning and then get you the answers you want. So a lot of frameworks like LangChain, LangGraph, or Crew AI or AutoGen make it easier to build these agents. So the models gets a task, break it down into steps, figure out which tools to use, invoke them and process a result, and then continue the loop until it reaches the goal. But as you integrate these agents with the tools, it becomes a bit messy of a lot of glue code, lot of integration required. Like you have 10 agents and 10 agents might be having 10 different tools, or sometimes same agent might want two agents might want a same tool. Then you need this lot of integration code. Agent 1 need to have some integration code, agent 2 need to have some integration code with these tools. It becomes too messy, it's hard to scale and debug and maintain. And that brings us to the next question: how do we make agents tool integration smarter, easier and more standardized? That's when MCP comes, and it is a real game changer. It is setting the standards is for someone to build the tools. In fact, it could be, I'm guess one of the things it could happen is that it might build a new business models, like you can host an MCP server with some tools, and then anyone can actually access that MCP server, MCP tools. It's like a pay as you go model. It could evolve into that in the future. Yeah, this is what we discussed, touched in the last slide, right? As you add more tools, you have too much glue code where every agent has to connect to multiple APIs. You need to build some custom wrapper for each tools. You have a lot of maintenance headaches. The challenge is, as of now, there is no standard way of talking to agents and tools. Just one way is that everyone is writing some API, some database calls, but it's still not completely a standard approach is not there. We'll see. And there is another challenges like with current APIs. We are going to talk about that before we actually understand what is an MCP server is all about. So let's talk about model context protocol. Before we actually see how it integrates with AI agents, let's understand what are the core building blocks of MCP. So an MCP mainly is having two components. One is an MCP host, which will have the MCP client. This MCP host could be your AI agents you are building. It could be an agent built using LangChain. It could be Claude Desktop, or it could be Cursor, anything which will have an MCP host with MCP client. And then we are having MCP server. That MCP server hosts multiple tools, right? So how does this client and server connects? When the initial connection happens between the client and server, they exchange the capabilities. MCP server says, hey client, I am an MCP server 1 and I have two tools. One tool called flight API tool, which will give the flight information. Another tool called hotel API tool, which will give the information about hotels. MCP server 2 will say, hey client, I am an MCP server 2 and I am having a tool called database tool, which would help you to get the data from local database about the sales information. How does this happen? Because of the specification you specified in the tool method. I'm going to walk you through that. You need to tell in the doc string of the method what is the method capability is all about, so that the agent will understand it and register it. Now, when depending upon the user question, if we ask you to book the flight, now the agent knows that the flight details are there in MCP server 1, and then it is having a tool called flight API tool, and then I need to invoke that tool to get the flight details. If you're asking question about the sales information from the last quarter, it knows that MCP server 2 is having a database tool, and then I need to connect to that tool to get the information about the sales data. Because when the client and server initially connects, they are exchanging information, and then the client is registering knows which server is having which capability. Okay, this is what the most interesting part when you compare to other regular APIs which you deal with the tools. Okay, now we'll also see what is the difference between this model context protocol and the API, and I'm also going to walk the detailed step-by-step walkthrough of two MCP servers, the code, so you will going to understand in very clearly what exactly how exactly the connection happens. Now let's understand the difference between a model context protocol or MCP versus an API. You might ask this question: MCP is pretty much doing the same job of an API. So what is the difference? How it is actually going to make my life easier? That's where, just take an example. You are having an API, and then to that API, currently that API accepts a location and the date, and it gives you some response about some travel plan. So at some point you added, this API has added another parameter called budget. Now any one client which is trying to access this API, unless you pass the budget, you are going to have a failure, right? You're not going to respond. This is a breaking change. That's why typically when we build the APIs, we have got version 1, version 2, version 3, so that the client which are connected doesn't have this problem. But any client which want to leverage new capabilities of the API, you still have to modify your code so that now you can pass a budget and get more accurate travel plan, right? This is a challenge with APIs. So imagine you have a building a production ready AI agent which is accessing some 50 hundreds of APIs. That means every time some API changes, you have to go and make changes to your code so that your agent will work as intended, right? Otherwise you are going to is going to be a breaking change. This is a big challenge with APIs. So how does the MCP actually address this issue? Is that the what I told you, when the initial connection happens between the client and the MCP with an API, they exchange the capabilities. MCP server says, I have this new capability. For example, in this case, I'm just putting very traditional language, like first time it says invoke me with the location and date. When you add a new parameter and then the agent and the client connects again, this time the MCP server say, hey, now you have to invoke me with the location, date and budget also. Now the agent knows that when next time I'm invoking this particular agent, I need to pass budget also. You don't have to change any code because the agent knows that I have to pass a budget, and then when the user says get me travel plan from Paris on this date within $1,000 budget, it knows that yeah, now user has provided me $1,000 budget. I need to pass this data also to the MCP servers, and then it will pass that data without doing any changes to the the code which invokes. That's a real power of MCP. It just not only standardizing the way you access the tools, it also helping you to build very clean glue code or plumbing code required to connect for the API. Now see the example. Now see with this advantage, as I told in the last slide also, you might have multiple agents, and then every agent don't have to you don't have to write when they had to connect. There's only one standard mechanism. There is an MCP server hosted. You just need to connect to that MCP server and then start accessing the tools within that MCP server. There's very clean way of accessing this tool. It brings the standardization required. It makes your agent code clean, less messy, and very easy to debug. If something goes wrong, you know where to debug, where to look for. So now let's look into the travel planner agent we are going to build to demonstrate its MCP capabilities. So in this case, we are having an AI agent using LangChain. We are building the agent. So user can ask, plan my trip with some start date, end date, destination, and then his preferences. And then this AI agent, which is a LangChain, is built using a ReAct model, which will do the reasoning, action, the thought, observation, that cycle. And then we are having two MCP servers. MCP server 1, we are having Amadeus Flight API, and then another API, hotels API. So this server is having two tools, and I'm having another MCP server which will give the location API, which will tell about the details about the location, and then an weather API which tells about how is weather conditions in that location during the user travel dates. And then we use DeepSeek as our LLM. So in the next few after this, I'm going to walk you through each MCP server 1. We'll open the server 1, we'll see, look at the code, we'll see how we write actually the MCP server and the tools, and then we'll see the React agent we developed using LangChain, and then we build some simple UI using Streamlit, and then when we enter the details, we'll see how the React agent does the thought, action, observation, how it connects to the MCP server tools. And this is going to be a really interesting demo. Please stay with me till the end, so that next we'll walk you through each and every MCP server and then the agent, and it's kind of a code walkthrough and demonstration. So before we get started, I would like you to go and then clone the GitHub repo so that you have got access to all the code. So all the code I'm going to show you right now is available in this repo. There are some prerequisites for run this. You need to get this, Amadeus API, SERPA API, and then Weather API, DeepSeek API, and then store them in environment file. They're all free APIs except DeepSeek. You can just pay like, even very cheap, you can just for a couple of dollars, you'll be able to run this entire demo. And then all the other APIs having a generous, free tier quota. So once you do that, then we'll go through step by step on what MCP servers we are going to build, and how we are going to build the agent, and how we are going to build the UI and connect the UI with the agent. So let's get started. Let's start with our most important thing, which is building our MCP server. Okay, this is our MCP server 1, which is travel MCP server. This server is having two tools. Tool number 1 is got flight tool, which gives you real-time flight information based on the source, destination, other parameters. Other one is hotels API, which gives you hotel information. So what is most important thing here is that when you initialize, you need to initialize with MCP travel services. This will initialize the agent, on a with this particular name, so that when agent connects, it knows that is the name of this particular MCP server. Now there is this tool decorator which you need to have on the method, which tells that this is a tool. And then what is the most important thing is this part, which is a get flight, this docstring part. This is how your LLM is going to understand what this particular method can do. LLM, that's what is excellent, any text based input, right? So you are telling LLM that your get flights method is having this parameter and this return this value. So that's what I was telling, when the MCP client and MCP server registers, they actually exchange this information. Now MCP client knows that this tool which is available is having this method, and this method is having, this is the input parameters for this method. Similarly, it is also having get hotels method, and then that is having these parameters. So these methods in turn are invoking the API. So if you can go to the API folder, you will find the flight search API, which is actually invoking a Amadeus client ID API. It is getting all the data in a JSON format and giving back to the MCP server tool. This is a regular API. There is not much anything new about here. What is new here is your MCP server. Now after doing all these things, you simply say MCP run dot transport SSE. SSE stands for server side events. You are telling this one mechanism to start the MCP server. So what we'll do is, now we have defined this MCP server. We'll go and start this MCP server. We run this server. Now we are having an MCP server 1, which is a travel service MCP running on port 8000. It is having two tools, which is get flights and get hotels. And then any client get connected to this MCP server knows that it is having these tools, and it knows that for each tool what is the input parameters it need to pass, and what is the argument type, and what it returns. Next, we have to look at our another MCP server called destination services MCP server. This is having two tools. One is called a weather tool, and then local events tool. Okay, so we are defining this MCP server. Here since by default this is running on 8000, I want to run on a different port. I'm specifying what port you have to run this particular MCP server. So this is running on port 5000. Now I'm having a get weather method which will take the source, the destinations, date range and tells what is the weather for that. And this is in turn invoking weather API, which is open weather API. You can find all the APIs it is invoking in this API folder. So you can take and weather API. And then you have another tool called get local events, which will get you, which is using the Google location API. And then that is also available in local attraction API. So you can refer these APIs here. Right, these are regular APIs, but what we have to focus more in this is that important is these MCP servers. Now let's run this destination service MCP server also. So I'm going to this folder here. Okay, I'm running destination service MCP. Now I have two MCP servers running. MCP server 1 here running on port 8000 with the available tools as get flights and get hotels. I'm having MCP server 2 running on port 5000 get weather, get local events. Now you are having two servers. They can give you the information you want, like real-time flight data, real-time hotels, real-time location information, real-time weather information, right? The next thing we need to do is build an agent which can consume these tools and then provide you what you want. So in our case, we are building an agent that will actually give us the travel planning, right? So we are building this agent using a LangChain, and then we are building a ReAct agent. So what is a ReAct agent? ReAct agent is something which will do a thought, action, and then observation. It will first do the thought about a question they're asking. It will take certain action using the tools you are provided. It will observe the output, and then it will take the next action. I will show you one example just for demo purpose only. I purposely made some mistake in the agent code, the input and pass agent code. For example, for the flight API, the API expect to be airport codes only, but I am purposefully passing the city names, just like Dallas or New York or Paris or London, like that, so that agent will fail initially. Then when it fails, when it sees observe the output, it will rectify itself again the input, and then this time it will send the correct input to the API. So just to showcase that, I purposely made give not passing airport codes, just to demonstrate that thought process agent of the agent. So here you can see that we are using DeepSeek LLM as our base LLM. We are just initializing our LLM over here, and then I'm having a generate travel plan method. Here I'm just reading the my URLs from the environment variable. These are MCP travel MCP URL or destination MCP URL. I'm reading. This is the most important thing. Like, you are connecting to both MCP servers using this way. So as I told, SSC is server side events. You get client tools. You are actually loading tools. Now this tools is having all the available tools from all the MCP servers, right? And then when you initialize the agent, you are saying use these tools, use this LLM and this agent type, and then this is the important thing. This is our user input. We are saying create a comprehensive travel plan for this origin, destination, these travel dates, number of travels, the budget, and then interest. Okay, now we are saying you must use the complete information. We are saying you must use only the tools provided by MCP servers. Very important, because agents a lot of times they hallucinate, they assume certain things. So to avoid that hallucination, what we do is we are actually equipping the agent with the information in the form of a tools. Now instead of agent assuming things, it will take the tools and then only the information provided in the tools it will use for its task. The task what we are given it is create a travel plan. Now to create a travel plan, it requires some information like flight, hotels, weather and local events. Now we are saying is that this instruction says use the tools provided, and agent knows what tool is having what information. In the end, we are saying return me strictly a JSON as output, because when I'm displaying the UI, it makes easier if I'm having a JSON as a output so that I can properly format the output in this one, right? So this is my agent and I'm invoking this agent. Now I want to expose this agent as API so that it will be easy to invoke from the front end. So I created a travel planner API. This is a fast API, nothing, it just a post method, regular API call, and then I'm just calling this API like this. Now we are going to run this, start this API so that it will start. Now let's travel planner API. So I'm running this API on port number 8001 here. I'm saying, UVCon I'm using port number 801. Now we are having two MCP server 1 with the flights and hotels, MCP server 2 with the local events and weather. We have an agent and that agent is exposed as API. Now all I need is to build a UI so that I can enter the information and hit these APIs. So to make job simpler, you can build using React, but just for our case, just kind of a proof of concept stage, I have built the using Streamlit. Streamlit is, if you don't know already, it is a tool which you can use to build APIs. If you're doing some proof of concept, instead of writing elaborative HTML code, everything, you can actually use the Streamlit to build this UI. So what I'll do now is I'm going to start the Streamlit app. I'm going to run this method. This will open the browser for me, and then now I'm having this Globe Genie, the product which we are having. So now I can provide the origin, destination, start date, end date, travels, and then choose the travel options. But once I hit, I want to show you the agent execution. I purposely made the verbose logs in agent so that you can see that thought, observation and action the agent goes through. So for our case, I'll say Dallas, and then let's say we'll go for London, okay, and these are my dates, okay, number of travels. I'll make budget medium. I can choose an option, maybe history, and then nature, okay, culture, like that, okay. So that it creates your itinerary based on that. Now I'll click on generate travel plan. It will take some time because the agent has to go through all this action thought process. It will take a few minutes actually before it can give a travel plan, but we'll see that how the agent takes care this one, okay. Now I'm hitting a travel plan. Let's head back to our this one. Now this is our API. You can see it is connected to MCP server first, okay, and then it is established in the deep sea connection, successful. Now it is entering agent execution chain, okay. So what is important? Connect MCP server and loading tools. It loaded the tools. Now it's saying the first thought, I need to gather all information for this step using available tools. First I'll check the flight from Dallas to London. So it has hit. Now the API failed. It says invalid format because API expired. Now we can see it is correcting himself. The flight search failed because I used airport code instead of city names. So I'll try again. Now it is again trying DFW, LHR, London Heathrow with the dates. Now it is getting all the data from that flight API. It is real-time data. It is getting all the API. Now it is saying now I have the flight options. I will search for hotels in London for the specified date that fit the medium budget. Now it has to go and get these hotels. It has got all the data in the JSON format from the hotels API. It has got all available hotels. Now the thought again happened. Now that I have a flight hotel option, I'll check weather for forecast London during the trip. Now it is invoking the get weather API. It got all the observation London, it has got all the city observation, everything. It has got all the for the dates, all the weather. This is all real-time information coming from APIs. Now it is checking for the local events with the history, nature and culture, right? And then it is invoking the Google location API, getting all the information. Now it is doing a thought again. Now it has got information of the flight. It has got the hotels, information, the local events, the weather, everything is there. Now it will take all these things. The final thought, typically now it says now I have all information to create a comprehensive travel plan. I'll compile a flight option, hotel choices. Now this is my final answer. So it picked up 2 flights for us, which are fitting in our budget. It picked up 2 hotels for us. It picked some local events, and then it created a detailed itinerary for me based on this one. Now I can head back to my UI. It displays in the UI like this: a trip summary, a 4-day. It picked up these flights, right? It is my account. Of course, the UI is very basic UI because it's Streamlit. Okay, you don't get, if you want really good UI, you can use React or Angular or Vue.js type of UI. It picked up some hotels. It did weather forecast. It gave the local events. It gave me detailed itinerary from day 1 to day 4, right? So this is what the power of now both the agent thought process which is going on, right? We have seen like how agent can actually correct itself when you present even the wrong information. So this is what actually most interesting part. When something failed, agent knows. The reason it knows is that we told in the tool that you have to pass airport codes, right? We are given a clear cut information, or maybe it is looking at the error message. It says that destination code must be a 3-letter code. Now it is able to find with this information. But of course, LLM is also having some information. It knows for this particular city what is the airport code. Okay, it has been trained on this type of information already. So it just can pass Dallas underneath, throw the dates and everything. It is able to get information. So this is about the how an agent can think and process. So in this whole demo, we are seeing how to create an MCP servers, how to build a React agent, and how the agent can consume these tools. That is the most important part of this demo. Okay, that brings the end of our session today. Hope you enjoyed it. Please leave me any comments, any more clarifications you want on this demo. Happy to take your questions and answer them. Okay, thanks for watching, and we'll meet again in another interesting session. Thank you.